SCAN 1302, Advances in Civil Integrated Management, is a part of the U.S. Domestic SCAN program developed by the American Association of State Highway and Transportation Officials and administered through the National Cooperative Highway Research Program, Project 20-68A. SCAN team members visited 7 state departments of transportation during the weeks of July 7th and August 4th, 2014 to examine highway construction projects that utilize civil integrated management technologies. In this video, 2 SCAN team members and the subject matter experts summarize what they found. Over the past 30 years, engineers have increasingly relied on computers to help design, construct, and manage transportation infrastructure. This includes collecting, organizing, and using accurate data about highways, bridges, and other transportation assets and how they are used, a practice referred to by the umbrella term Civil Integrated Management, or CIM.
Traditionally, civil engineers in the transportation field have relied on two-dimensional drawings, printed specifications and contract documents, traditional surveying techniques, and other common methods such as those to deliver their transportation infrastructure projects. With recent technological advances, civil engineering has progressed to where everything is being produced in digital format and is accessible to all users involved in the project.
CIM includes the use of advanced tools such as global positioning systems, computer-driven total robotic stations, light detection and ranging laser guidance systems, automatic machine guidance systems, 3D, 4D, and 5D modeling of complex construction strategies, visualizations of challenging bridge assembly processes, traffic control center analyzers, and financial monitoring systems.
Ultimately, CIM is about making better decisions and helping to increase accuracy and efficiency in a wide range of areas, including planning, environmental assessment, surveying, construction, operations and maintenance, asset management, and risk assessment.
To examine the use of CIM technologies, NCHRP Domestic SCAN 1302, Advances in Civil Integrated Management, conducted on-site visits to several host transportation agencies and projects. 1302 also examined partnering efforts between state DOTs, consultants, contractors, and materials suppliers.
One of the key lessons of the SCAN was the centrality of the data. CIM enables and is enhanced by seamless data flow over the life cycle of a project, meaning that data access, management, and interoperability between various systems are vital.
Agencies in the process of implementing CIM should establish a data warehouse early on, with information on both existing transportation assets and ongoing or planned projects. Agencies should determine early on what data is useful and how to store it and manage it so it's accessible to all who could benefit from it.
Beyond the focus on data, agencies implementing CIM could consider starting with a model-centric design and conduct pilot tests to demonstrate the benefits and challenges of using these technologies.
Iowa started their Civil Integrated Management efforts, or CIM efforts, in 2003 by working with vendors, contractors, and equipment manufacturers to supply them with digital designs. In 2009, Iowa moved to 3D design and is now 100% digital from project development through construction. When the Iowa DOT started 3D modeling, we met with equipment manufacturers to assess the future of the technology, adjusted our agency goals accordingly, and initiated a pilot project. We found that 3D modeling improved communication, made the design more easily understood, improved safety in the field, and reduced cost.
The SCAN also found that there are important organizational considerations when CIM is implemented. It requires that there be a culture of sharing information among stakeholders and that agencies establish procedures facilitating communication and data accessibility.
One of the projects visited during the SCAN had several suppliers tied into their materials management system with an electronic portal that allowed coordination with subcontractors and suppliers. They are seeing significant benefits from the efficiency of these efforts.
Ultimately, CIM requires support from stakeholders, including agency leaders, consultants, contractors, suppliers, and utilities.
The decision-making process for transportation projects is challenging due to the many constraints and the many stakeholders with varying perspectives. Civil integrated management implementation can facilitate data-driven decision-making that leads to transparency, objectivity, and efficiency in the design and construction of our transportation projects.